Okay, hello everyone. In a new video, so we have reached part 6 of chapter 2, which is the chapter of electric voltage for grade 10 students. So exercise number 15, they are telling me the adjacent figure, they mentioned the figure, so now we can use it, shows 5 identical lamps connected to a battery. An oscilloscope is connected across the terminals of the dry cell. We observe a luminous line displaced upward by 3 divisions. Okay, so Y is equal to plus 3 divisions and a luminous line. In number 1, they are telling me what will we observe on the oscilloscope screens in the absence of sweeping. We know that in the absence of sweeping we will observe a luminous spot. It will be either displaced upward or at the center or downward. Since previously the luminous line is displaced upward, so let's say since the luminous line is displaced upward, and in the absence and the sweeping is turned off, switched off, then we will observe a luminous spot displaced upward. Now in number 2, they are telling me calculate the voltage UPN, knowing that the vertical sensitivity is SV is equal to 5 volts per division. So notice that here the oscilloscope can either measure UPN or UNP, knowing that UPN is positive and UNP is negative, and the luminous line is displaced upward, so it's measuring a positive voltage, which means UPN. So the value of SV is given by 5 and the value of Y is positive 3, so it's given by 15 volts. Then in this case UPN is equal to 15 volts. So the trick in solving such type of exercises is to label the voltage on the electric circuit itself. So here we have that UPN is equal to 15 volts. And now in number 3, they are telling me suppose K1 is closed and K2 is open. So this is closed and the other switch is opened. So before we complete the question, let's do the following analysis. Notice that in this case the terminal F is a disconnected terminal, and a disconnected terminal, because the switch K2 is open, a disconnected terminal can be simply considered as a connecting wire. Okay, so now they are telling me determine the potential difference across each lamp. So here we have 5 lamps that are identical. So let's start by the lamps L1 and L2, and let's say since a disconnected terminal can be considered as a connecting wire, then in this case UAC, the voltage across the lamp L2 is 0, and UCF is equal to 0 for the same reason. Since it is a disconnected terminal, which can be considered as a connecting wire. Notice that I'm mentioning UCA and UFC and not UCF and UAC, UCF and not UCA and UFC, because we are measuring from positive to negative. Okay, so this is the positive pole and the negative pole. So here, because they didn't mention the voltage across each lamp, we are free to choose UCA or UAC, but we are measuring from positive to negative. Now regarding the lamps L3, L4, L5, they are connected to the battery, because notice that this loop is a closed circuit. And in order to determine the voltage across each lamps, because they are identical, then first we need to determine the potential across these lamps, which is given by UAB. And this can be done by the law of addition of voltages. Then let's say apply law of addition of voltages. So for the identical lamps, let's first calculate the voltage UAB. So how do you apply this law? Always on the left we write the voltage that you are interested in calculating, which is UAB. And on the other side of this equation, we'll go from A to B across different electric components. So let's say UAP plus UPN plus UNH plus UHB. And in this case, UAP is equal to 0, and the reason is given by a connecting wire. As for UPN, is given by 15. Across N and H, we have a closed switch. And across H and B, we have a connecting wire. And in this case, UAB is equal to 15 volts. Now, after we have determined the potential across these three lamps that are identical, we can say that since, UAB is equal to 15 volts. Now, since are identical, then they have the same voltage. Now let's translate the following statement into a mathematical formulation. So what is the voltage across the lamps? They are given by AD, DE, EB. Recall that you are measuring from positive to negative. Sorry, here I'm talking about the lamps L3, L4, L5. So let me say, starting from L5, L4, and L3. So the voltage of the lamp L5 is given by UAD, which is equal to the lamp L4, which is UDE, which is equal to the voltage of the lamp L3, which is UEB. So now these points will vanish, and we are left with the voltage UAB divided by the number of lamps of electric components that are given by 3, which is equal to 15 divided by 3, which is equal to 5 volts. Now in this case, UAD is equal to 5 volts, UDE is equal to 5 volts, and UEB is equal to 5 volts as well. So now in part 4 they are telling me the two switches are closed. So now we'll close the switch K2. Now again, 4.1, determine the voltage across each lamp. So here nothing changed between the points of A and B, but we will repeat the same exact calculation just to show that nothing will change. So we are in part 4, 4.1. So we can calculate again UAB. So okay, before first calculating UAB, now since K2 is now a closed switch, so the point F now is not a disconnected terminal, it's a connected terminal. So we should consider the lamps L1 and L2. So in this case, first let's determine the voltages across the lamps L2 and L1, knowing that they are identical. In order to do so, we need to determine the voltage UAB. But notice that we have previously determined the voltage UAB to be 15 volts, so we will not repeat the calculation. We will simply say that since L1 and L2 are identical, then they have the same voltage. Now let's translate this statement into a mathematical formulation. The lamps the voltages of the lamps L1 and L2 are given by UAC, which is equal to UCF. Now eliminating this point, we are left with, okay, so here notice that the potential, so instead of writing UCF, okay, between the brackets here, let me say that because between the points B and F we have a connecting wire, so the potential at the point B is equal to the potential at the point F, okay, which means that UCB is equal to UCF is equal to UCB. So the voltage from C to B is equal to from C to F. So knowing that UCF is equal to UCB, simply because now UCF is VC minus VF, and this is equal to, or we can prove it in another way. Let me say that apply law of addition of voltages. So UCF is equal, or let's say UCB is equal to UCF plus UFB, knowing that UFB is equal to 0, and the reason is given by a closed switch. So in this case, this is equal to UCF plus 0, so UCB is equal to UCF. So now replacing UCF by UCB, we get that UAC is equal to UCB. Now we can eliminate this point, so it's given by UAB divided by the number of lamps that we have, which is given by 2, which is equal to 15 divided by 2, which is equal to 7.5 volts. So why I have replaced UCF by UCB? Because we know the voltage UAB, and in order to apply this rule here, we need to eliminate this point. If we have here UCF, then it will be given by UAF, but in this case we have UAB and not UAF, okay? So in this case we have that UAC is equal to 7.5 volts and UCB is equal to 7.5 volts. So UAC is equal to 7.5 volts and UCB is equal to 7.5 volts. Now it's left to determine the voltages L5 across the lamps L5, L4 and L3, and this is exactly the same as we have done in number 3, but let's do it again. So knowing that UAB is equal to 15 volts, let's say since L5, L4 and L3 are identical, then they have the same voltage. So in this case UAD is equal to UDE is equal to UEB is equal to UAB divided by 3, which is equal to 15 divided by 3, which is equal to 5 volts. So the voltage across of each lamps is given by 5 volts. Okay, so UAD, UDE and UEB is equal to 5 volts. Now in 4.2 they are telling me to calculate the potential difference UCE, and this can be done using the law of addition of voltages. So apply law of addition of voltages. So in this case the voltage that you are interested in calculating is UCE. So we have several ways from going to C to E. We can go from C to F, F to B, B to E, but the closest path is from C to A to D. Sorry, from A to... Okay, so actually the closest path is from C to F, F to B, and B to E. Let's use it. So C to F plus F to B plus B back to E. So notice that I have started with the same point, ended with the same point, and each letter that I have inserted it twice. So now the value of UCF is given by 7.5, UFB is equal to 0 justified previously, and UBE, if UEB is 5 then UBE is minus 5, then this is given by 2.5 volts. Then in this case UCE is equal to 2.5 volts. Now in part 5 they are telling me K1 is open. Let's open the switch. So all the voltages will change. And eventually they are telling me K1 is open, indicate with the justification the voltage across K1. So notice that now K1 represents an open switch in series with a battery. So an open switch in series with the battery has the same voltage of the battery, which is given by 15 volts. So notice that now in this case we can distinguish between two voltages that are given by UNH and UHN. So they didn't ask me about which voltage, so we can directly just place the value. But if they are asking me about UNH, UNH will be minus 15 volts because we are measuring from negative to positive. Otherwise UHN, H is connected to the positive terminals, H to N is the negative, so this is given by plus 15 volts because from positive to negative. We can just directly say 15 volts because an open switch in series with the battery have the same voltage of the battery. Now as for exercise number 16, they are telling me the adjacent figure, they mentioned the figure, now we can use it, represents a part of an electric circuit denoted by ABCD. A digital multimeter is placed in parallel across A and C. Recall that multimeter means it is an instrument that can be used either as an ammeter or voltmeter. Here, since we are connected in parallel, then it's a voltmeter. So you are using it as a voltmeter across A and C. So this is the voltmeter. Such that C is connected to the comb of the multimeter. So this is the comb. The reading of the multimeter is minus 2 volts. Number 1, they are telling me which voltage UAC or UCA is being measured, and this depends on the comb terminal. So let's say since the comb terminal is connected to C, and the other terminal is connected to A, then the multimeter measures. So it will either measure UAC or UCA, but always the comb terminal is related to the second letter, then in this case it measures UAC. Now in number 2 they are telling me in which direction does the current flow in part ABCD of the circuit. So in order to determine the direction of the flow of the current, we need to determine which point is considered to be higher potential. So notice that here, because the voltmeter is measuring UAC, so the value of UAC is equal to minus 2 volts. So always the trick in this exercise, such type of exercise, is to label the voltage on the electric circuit in addition to their names, in addition to their labels. So knowing that UAC is equal to minus 2 volts, which is negative, so UAC is equal to minus 2 volts, then in this case VA minus VC is equal to a negative number. Then VA minus VC is negative, which means that VA is less than VC. Now since VC is greater than VA, okay, let me say that since the point A has higher potential, the point C has higher potential compared to A, the point C has compared to A, then the electric current traverses the branch CA or AC from C to A. So always the electric current traverses a branch from the higher potential to the lower potential. So in this case the electric current will be like this. Now they are asking me about how the flow of current from in the part ABCD. So we have determined from A to C. Now in this case from C to in the branch CD, it will be also from D to C. Okay, so because the direction is the same for all of this branch. So in this case from D to A. So always the direction of the electric current is from higher potential to lower potential. Now in number 3 they are telling me the multimeter is now disconnected. Let's disconnect the multimeter. Points B and C are connected to channel 1 of an oscilloscope. So this is the channel 1 of the oscilloscope. Points C and D are connected to channel 2 of the oscilloscope. This is the channel 2, such that in both cases C is the mass as shown in the above figure. So here we have one oscilloscope having a common mass, but two channels Y1, Y2 of respective vertical sensitivities SV1 and SV2. Shown in the above figure, the luminous lines are initially centered, so this is important for the reading to be accurate and correct, and the vertical sensitivities of the two channels are given by these. Notice that because the unit of the sensitivity is given by volts per centimeter, then the unit of Y will be expressed in centimeters. So in this case, they are telling me calculate UBC when the luminous line is displaced by 3 centimeters. So notice that UBC is related to channel Y1, channel 1. So UBC is equal to Y1, so SV1, Y as V1, because UBC is being connected across the channel 1 having the sensitivity 1 multiplied by Y1. So we know the value of SV1. It's left to know the value of Y1. They are telling me when the luminous line is displaced by 3 centimeters, but they didn't tell me whether Y1 is positive or negative. So here we have that Y1 may be plus 3 centimeters or Y1 is equal to minus 3 centimeters, and this can be determined by referring to the sign of UBC. So notice that here Notice that the electric current is being traversed from C to B. So let's say, since the electric current traverses the branch BC from C to B, then the point B has higher electric potential compared to C, which means that the point C has higher electric potential compared to B, which means that VC greater than VB. So VC minus VB is positive. So dragging VB to the left hand side, it will gain a minus sign. So in this case, UCB is positive. Okay. So if UCB is positive, which means that UBC is negative. Okay. So this is important that UBC is negative. Since UBC is negative, then the luminous line will be displaced downward. So in this case, it's displaced by minus 3 centimeters downward. So now we are ready to calculate UBC. So UBC is equal to SV1 multiplied by Y1, which is the value of SV1 is given by 0.2. Y1 is negative because UCB is positive, so UBC is negative. UBC is negative means that the luminous line is displaced downward, so minus 3. Plugging this on the calculator, then the value is given by minus 0.6 volts. So UBC is equal to minus 0.6 volts. So now we have UAC and we have UCP. Now in part B, they are telling me to calculate UDC when the luminous line is displaced by 3.5 centimeters, and notice that UDC, so we need to use the oscilloscope, is being measured by channel 2 of the oscilloscope, so we need to use Y2 and SV2. So this is equal to SV2 multiplied by Y2. So the value of SV2 is given. Now we need to determine Y2. Y2 is also given, which is given by 3.5 centimeters, but they are telling me it's displaced by 3.5 centimeters. So Y2 can be either plus 3.5 centimeters or Y2 is equal to minus 3.5 centimeters, and this depends on whether UDC is positive or negative. In order to know whether UDC is positive or negative, we need to follow the direction of flow of current. So notice that since the electric current traverses the branch DC from D to C, then the point C, the point D, has higher potential compared to C, which means that VD is greater than VC. So this is an inequality. Dragging VC to the left hand side, it will gain a minus sign. So in this case, UDC is positive. So knowing that UDC is positive, so the luminous line will be displaced upward because we are measuring UDC. So in this case, Y2 is equal to plus 3.5 centimeters. So UDC is equal to SV2 multiplied by Y2. The value of SV2 is given by 0.5 and the value of Y2 is positive. The number of divisions is 3.5. Plugging this on the calculator, then the value of UDC is given by 1.75 volts. So UDC is equal to 1.75 volts. And the trick in solving such type of exercise is to label the applied voltage on the electric circuit itself. Now in part C they are telling me the vertical sensitivity of channel 2 is changed to 1 volts per centimeter. What is the value of the displacement of the luminous line? So here we have two luminous lines corresponding to first channel and the second channel. Because we have changed the settings of channel 2, then the number of or the value of y2 will change. So they are asking me about the value of y2. We know that SV2, y2 and UDC are related via the following formula. Why to UDC? Because simply channel 2 is related to UDC. Knowing that you are interested in determining y2, the value of the displacement of the luminous line, notice that UDC didn't change because this is an applied voltage. We didn't change the settings of the electric circuit itself related to the source and related to the components. So the value of UDC is given by 1.75, and we know the new value of the vertical sensitivity. So what's the type of this equation? This is an equation in one unknown. How do we solve it? We put y2 on one side and all the others on the other side. So flipping this equation, we have that SV multiplied by y2 is equal to UDC, knowing that we are interested in y2. So we need to get rid of SV2 or move it to the right hand side. So here it's multiplied, dragging it here, it will be divided. Then y2 is equal to UDC divided by SV2. The value of UDC is given by 1.75, dividing it by 1, so this is equal to 1.75. Now, because everything is expressed in the SI, so the value of y2 will be in the SI. Notice that since this is volts per centimeter, so this will be expressed in centimeters. Then y2 is given by 1.75 centimeters. And the value of y2 is positive because simply the voltage that you are measuring is positive, okay? So it's displaced. Instead of being displaced upward by 3.5, it will be displaced upward by 1.75. Now in part D, they are asking me to calculate UDA. So we are interested in determining UDA, and this can be done by the law of addition of voltages. So always on the left, we will place the voltage that we are interested in, which is UDA. And on the other side, we'll go from D to A across different components such that we know their voltages. Now we can go from D to C because we know UDC. Now, we cannot go from C to B because yet we don't know the voltage UCB. However, we can go from C to A because we know UAC. Now the value of UDC is given by 1.75. Because UAC is given by -2, then UCA is +2. So this is given by 3.75 volts. Then UDA is equal to 3.75 volts. And this is a reasonable answer. Why? So notice that the electric current in this branch is being traversed from D to A. So D is considered a higher electric potential compared to A. So VD is greater than VA, which means that UDA must be positive, and this agrees with our result. Now as for the voltage UAB, we can also apply the law of addition of voltages. Knowing that the voltage that you are interested in, which is UAB, now we need to go from A to B. So, okay, notice that we can go from A to C because we know the voltage UAC. And, okay, then we can go from C to B because simply we know the voltage UBC. So the value of UAC is given by -2. As for the voltage UCB, if UBC is equal to -0.6, then UCB is 0.6, and this is given by -1.4 volts. So UAB is equal to -1.4 volts, and this is a reasonable answer. Why? Notice that the electric current in this branch is being traversed from B to A, so VB is greater than VA, which means that UBA is positive. If UBA is positive, then UAB is negative, which is in agreement with our answer. And as for the final exercise, which is exercise number 17, they are telling me a student connects a 1.5 volts battery with two lamps L1 and L2. So the voltage of the battery, which is given by UCE from the positive to the negative pole, is given by 1.5 volts. A voltmeter and an oscilloscope are connected between the terminals A and B of lamp L2. So notice that across the lamp L2 we have the voltmeter and we have the oscilloscope as well. And here let me be very clear. They are telling me a voltmeter and oscilloscope to the terminals A and B of lamp L2. So the voltmeter is already connected to the terminals A and B, but the oscilloscope is connected to E and M. But notice that between B and E we have a connecting wire, so E and B are considered as the same point. The same goes for the points M and A. So here in this case, UAB is simply equal to UME, okay, because these 2 points are identical, because what's connecting M and A is a connecting wire and what's connecting B and E is a connecting wire. The luminous line of the oscilloscope displaces downward by 3 cm, so Y is equal to -3 cm. The minus sign corresponds for the downward displacement. And number 1, they are telling me show on the circuit the COM terminal of the voltmeter in order to measure UAB. Notice that the COM terminal is always related to the second point, since the COM terminal is connected to B, since the voltmeter measures UAB, then the COM terminal is connected to is connected to B, and the other terminal is connected to A. So in this case, this is the COM terminal. Now in number 2, the voltmeter has the scales 100 millivolts, 300 millivolts, 1 volt, 3 volts. So 100 millivolts is given by 0.1 volts and this is the 0.3 volts. When the voltmeter is adjusted to a 3 volts scale, S is equal to 3 volts, the reading will be 0.9 volts. So notice that here the voltmeter is reading which applied voltage? The voltage across the lamp L2. So UAB in this case is equal to 0.9 volts. Okay. Is the used scale the most adequate? The adequate means the convenient. In order to justify or to interpret this question, first let's refer to the definition of the most convenient scale. So the most convenient scale is the one having a value slightly greater than the one to be measured, if not, what scale do you propose to use? Justify. So notice that the applied voltage is given by 0.9 volts and independent of the used scale. The scale that we are using is 3 volts. Notice that this is not the convenient scale, because among the following the closest to 0.9 is 1 volts and not 3 volts. So in this case it is 1 volts and not 3 volts. So notice that the applied voltage, the value of the applied voltage is independent of the use scale. The thing is that whenever we use a scale which is more convenient or most adequate, the reading of the multimeter will be more accurate, okay? Or easier to read. Now in number 3 they are telling me to calculate the vertical sensitivity of the oscilloscope, and this can be done by U is equal to SV multiplied by Y, but here first we need to refer to the voltage measured by the oscilloscope. So the oscilloscope is measuring UBA. So let's say since the phase terminal is connected to E, the point E is considered the point B, and the mass terminal is connected to M, which is the point A. Then the oscilloscope measures UBA. So UBA is equal to SV multiplied by Y. Notice that here we only have one channel, no need to distinguish between channel number 1 and channel number 2. So we are simply interested in determining the value of Y. Flipping this equation, we have that SV multiplied by Y is equal to UBA. So Y, now dragging SV to the right hand side, it will be divided. So Y is equal to UBA divided by SV. Sorry, we are interested in determining SV. So flipping this equation, SV multiplied by Y is equal to UBA. Now dragging Y to the right hand side, it will be divided. So SV is equal to UBA divided by Y. So notice that if UAB is equal to 0.9, then UBA is minus 0.9. They are telling me Y displaced downward by minus 3. Plugging this fraction on the calculator, then it's given by 0.3. Why 0? Okay, 0.3. So, and as you can notice, always the value of SV must be positive. It's sign independent. Now, because U is expressed in the SI and Y in the SI, so SV will be volts. Since the displacement is in centimeters, and this is given by V as centimeters, so this is volts per centimeter. Then the vertical sensitivity of the oscilloscope is given by 0.3 volts per centimeter. Now in number 4, they are telling me the point C in the circuit is now connected to the face of the oscilloscope instead of B. So instead of connecting the face of the oscilloscope to the point B, it's being connected to the point C of the circuit. Explain what you observe on the screen of the oscilloscope. So here the sweeping is still turned on. We didn't mention the sweeping till now. And it's turned on because at the beginning we observe a luminous line. Now what we observe, we will either observe luminous lines spaced upward, downward, or at the center. So in this case, the oscilloscope, okay, measures UCM, and UCM in this case is positive. We can prove that UCM is positive. So let's calculate UCM and prove it is positive. UCM can be calculated using the law of addition of voltages. So apply law of addition of voltages. Now, since the phase term is connected to C and the mass term is connected to M, then the oscilloscope measures UCM, which we are interested in calculating. So UCM, from C we can go to E, from E we can go to B, and from B to A, and A back to M. And you know that UCM will be positive because we are measuring from positive to negative. But let's prove it using the law of addition of voltages. UCE is equal to 1.5 voltage of the battery, UEB is 0, so let's justify here that UEB is equal to 0, and the reason is given by connecting wire. Then UBA is equal to minus 0.9 because UAB is 0.9, and UAM is 0, and the reason is given by a connecting wire. So this is given by 0.6 volts. So UCM is equal to 0.6 volts, and we can say that the oscilloscope is measuring UCM because phase is at C and mass is at M. So if UCM is positive, let's say since the phase terminal is connected to C, and the mass terminal is connected to M, then the oscilloscope measures UCM, which is positive. Since the oscilloscope measures positive value, which is UCM is positive, then the luminous line will be displaced upward. Here, no need to mention by how many divisions because the question is clear. They are telling you just what do you observe, okay? They didn't tell me and by how many divisions. Then we will observe a luminous line displaced upward. So the luminous line is displaced upward. Now in part B, and since here we have calculated UCM, let me specify it on the circuit. So UCM is equal to 0.6 volts. They are telling me in part B we modify the vertical sensitivity of the oscilloscope such that the luminous line gets displaced by 1.5 centimeters. So Y is equal to 1.5 centimeters, and here they didn't specify whether it's displaced upward or downward because we know that it's upward and it's measuring UCM, so we will place here a plus sign. So it's displaced upward by 1.5 centimeters. Calculate the modified vertical sensitivity, and this can be done using the relation UCM is equal to SV multiplied by Y, knowing that you are interested in determining SVY UCM because we have justified that the oscilloscope is measuring UCM. So flipping this equation, SV multiplied by Y is equal to UCM. We are interested in determining SV, moving Y to the right hand side, and it will be given by SV is equal to UCM divided by Y. The value of UCM is given by 0.6. The value of Y is given by 1.5. Plugging this fraction on the calculator, then the value of SV is given by 0.4. Since everything is expressed in the SI, so SV will be in the SI, which is volts. Since Y is expressed in centimeters, so this is volts per centimeter. Then SV is equal to 0.4 volts per centimeter. Now in part 5, they are telling me what happens if the horizontal sweeping is stopped. So we will observe a luminous spot. Since the luminous line was already displaced upward, so the luminous spot will be displaced upward. Since the luminous line is displaced upward, and the sweeping is switched off. Then we will observe a luminous spot displaced upward. So that's it for me in this video, guys. In the next part 7, we'll complete solving exercises on this chapter.